Okay, welcome back everybody to the second half of our meeting, and the main part of the meeting, in fact. What we'll do for you is just go over the Zoom controls for anyone who doesn't know them, how to use them. I think we're all getting a bit used to using them now. If you have any questions for our speaker tonight, you'll see that there's a little Q&A button at the bottom. Just click that, put your questions in there anytime throughout the talk, and Rich will pick up on those, and you'll then ask them over to Matt. Okay. You'll also notice that we've got closed captions running at the minute. This is for the benefit of the hard of hearing. If you don't want these on, you'll see there's a live transcript button with CC above it. You click into that and that will turn the captions off. If you want them on, you can move that anywhere around the screen if it happens to get in the way of the presentation. There's also the chat button. See, people have found the chat there. We will turn this off during the main talk though, because it does get a little bit disorientating for both the speakers and everyone else trying to watch the presentation. But we'll come back on at the end of the talk. Just a little note, don't forget we're having the members gathering after this. Please do come along. We'll have a quick natter. I don't think I'll be staying too long because I had my second COVID jab yesterday and I'm feeling a little bit under it today, as I say, but I will come along for a little while. That will be in a different room, but we'll give you a bit more information about that at the end. Okay. So on to tonight's main feature. It gives me great pleasure to welcome back to Sigma Matt. Matt is a researcher studying innovation and development in astronomy, space exploration, and planetary science technology at the Institute for the Study of Science, Technology, and Innovation. He lectures, tutors, and mentors at various University of Edinburgh courses, and is currently conveying the Marketing Technical Product course at the School of Engineering. I believe that is right. Matt is based at the ROE and his work is closely linked with the project run by the Institute for Astronomy and the FTFC. In particular, the ATC innovations. In addition, he works closely with the data-driven innovation space and a space innovation program. There's some wonderful names here, isn't there? It looks at developing a set of strategies leading to Edinburgh becoming a space data capital of Europe and the University of Space and the University of a Space University. Also, Matt is the chairman and policy lead of the Gateway Earth Development Group and the deputy chief executive officer for the program and specialist project engine for Europe at the Astropsychology Research Institute. In addition, he co-funded 2 new research networks, the Scotland Social Dimensions of Outer Space Network and the International Social Studies of Outer Space Network. He does quite a bit, does our Matt here. Tonight, we'll be taking a look at how space is changing our view of the world. He will also be telling us about the latest project that launched, an app that launched just yesterday called Awen, A-W-E-N. If you want the link, it's already on our website in useful links. It's sort of how you can get involved in that. He's going to tell us a little bit more about it. I won't say too much. I will hand over to Matt and let him tell you all about it and the other things he's been up to. So Matt, it's over to you.
Thank you very much, Pete, and good evening, everybody. And thank you for this mouthful of an introduction. I apologize for my various roles and titles. We probably could have skipped through half of them because a lot of it sounds a lot grander than it actually is.
That's fine.
We've all met before.
You're very down to earth, man.
I do a bit. I'm super interested in space, and my sort of exploration of the space and space industry and astronomy sort of spans quite a wide array of activities. In fact, we first met with the Sigma team doing some public outreach further up north in Orkney. We're just reminiscing about that during our rehearsal the other day. So it does cover quite a variety of different aspects. So Thank you again for having me back. Not like Pete, but I had my job today. So if I start dozing off in the middle of the talk, it's not of any disrespect, but because it's just kicked in at the most inopportune moment. But hopefully that does not happen, and we managed to get through as quickly as possible. And I really do. Pete's already mentioned Q&A. I really do welcome any questions you might have. I try to synthesize effectively. Those of you who might remember my talk from the first time when I visited, I spoke a lot about the development of Scottish space industry, and in particular about rockets and small satellites. That's super exciting, of course, because there are spaceport coming to locations near you, and there's, of course, right now quite a wide-ranging debate around that. But today we'll talk, basically, I'll continue on. So if the first bit was about how stuff goes into space and what is going into space, particularly going to space from Scotland, the second, this talk will basically be, so what are we actually doing with all this stuff in space? And surprise, surprise, vast majority of it is not to look out there into the magic of the universe, like the stuff behind me, but it's actually all pointing back down towards the Earth, and these sort of what called space assets, satellites out there, are really changing our worldview more than they are actually, enabling exploration further afield, and they're changing the way we look at our own planet. So I hope you can see my slides now.
Yep, we've got that. Over to you.
Perfect. So it's a brief sort of whistle-stop tour of some of the things that are happening again. We start with Scotland and things that are really kind of near us, and in particular, both in terms of what does that mean for the Scottish space industry, what is the data that's coming down from space actually doing in order to understand more of our environment, and some really specific examples of that. But then also, and I think this is what Pete's been referring to, this mysterious project we've launched yesterday. So if Pete has outed me as having compiled my slides rather late in the day. I think a relatively better excuse than I normally do, which is that not only some of the stuff we were really working on until yesterday, but also it has been an incredibly busy week, and this wasn't entirely planned to be this way. So we were kind of working after the wire. But in any case, there's a big additional aspect of space and satellite data, which is that it feels quite mysterious and often quite disconnected from the everyday life. And the project that I'm going to mention and hopefully encourage you right at the end of the talk to actually go and use it this weekend if the weather stays nice, and go for a walk with Owen, then it is about actually bringing a connection between this kind of global space data, satellite observations, and your everyday life a little bit closer. So hope that works. All right, let's have a quick, and as I say, very welcome questions, and I hope I'll try and wrap this up sooner rather than later, and so we have a good some time for discussion. So yes, so why am I so interested about space? Where is all this work coming from? To begin with, I'll start with effectively where we've left off the last time I visited you, and I was hoping that this time around again I'll be able to actually see you all in Elgin, but that wasn't to be. When I was first approached to do this talk, we were still hoping that by this time we will all be back to meeting in person, but hey ho, maybe for the next visit if you ever do want me back after this talk. But here we go. So I've done my PhD, in fact, a lot of research. Basically over the past 7 years I've been working on researching the development of space industry in Scotland. And space industry in Scotland is an interesting thing because it has it has all elements of what a big space industry would have, but on a small scale and dispersed rather than in one place. Like we talk about sometimes with IT we talk about Silicon Valley, the Space Coast in Florida. It's a place, and of course there's a lot of engineering and bits that are developed all over the US. But it feels like there's a kind of a natural center in a particular place where space is sort of anchored. In Scotland, it's far more dispersed. And whilst a lot of the action is for obvious socioeconomic and political reasons down in Central Belt, that is being spread up further north with the spaceport, etc. And even the Central Belt is quite dispersed, actually. There's clusters in Dundee, in Glasgow, and the one in Edinburgh. Again, where we've left off last time, I was talking about the rockets being built and satellites, satellites being built in Glasgow, rockets being built and developed for launch from this northern spaceport. And I kind of skirted just, well, in Edinburgh, we do data science. And that's really where all the money has been made. And this is not just a kind of an Edinburgh joke. It is true. You know, the applications, the point at which space data and space assets become useful to companies and to people in their everyday life, that's really where the space industry is making money. And from that point of view, in an interesting way, the space data cluster in Edinburgh is super important in anchoring the industry. I've been doing lots of things. This is just to show you that, you know, I'm not just telling you this from the top of my head, that we've done sort of no social network analysis and modeling, and we've interviewed companies and talked about them, who do they work with, and the thing that we found at the core is a lot of the companies that are right at the center of the space industry in Scotland are actually sort of what we call sort of downstream companies, which basically means they are developers of space data applications. Now, what we mean by space data, we'll talk about later, but basically the whole point is that at the center of Scottish space industry is an awful lot of data analytics, data processing companies, as well as research, particularly in Edinburgh at the School of Geoscience, where a lot of this sort of scientific principles behind the data processing from space is actually all developed. Here's a slightly prettier picture that explains, again, this sort of agile space idea, this sort of, I think in my previous talk. So those of you who still remember, it's basically the idea that, you know, if you go across Scotland, you have the whole hog. You have the people that build small satellites, people who make the rockets, people who can downlink the data, particularly the data at the Dundee Satellite Receiving Station. And then finally, I've mentioned that corner, the all-important data applications. And you really see there, you know, two companies with specific sort of GPS and Earth observation data who are providing these sort of applications. What you have there is effectively screenshots of their applications that they sort of, you know, sell to their clients, where, you know, the bottom one is actually Topolytics. They're tracking lorry bins for companies to manage waste disposal and provide both the regulatory reporting as well as sort of operational management of waste disposal in cities. And Ecometrica up there, I mean, Ecometrica is a wide-ranging company with, you know, probably the largest space data company in Scotland, maybe bar one. And you know, the image you see there is actually not in the UK, that's the Netherlands. And they're mapping crops, they're mapping you know, carbon sequestration. They do all sorts of interesting things, again, sometimes in reporting, sometimes in operations and management. And as I say, this is, you know, in the end, vast majority of people, you know, say, well, we'll launch a satellite. Well, they'll be like, okay, that's interesting, but, you know, what does the satellite do? Like, you know, why are you telling me about that? And, you know, and they're like, well, we need money for the satellite. Well, the satellite itself isn't really what you're ever going to sell. I mean, even the really big satellites that have been built by, you know, big international space companies like, you know, Airbus Defence and Space or Lockheed Martin or any of these ones, you know, they're not sold to the government. What they are selling to, you know, corporations and even private individuals is images. Then you never sell, you know, time on a satellite. You always sell the product, which is, of course, the analytical data that comes down from space. And so, as I say, this is where money is made. Here's a little animation of some of the larger and perhaps most dominant companies. Not went through too fast. That are based predominantly in Edinburgh. As I say, this is a slightly Edinburgh-centric talk, but we are reaching out and we are expanding further north with the Space and Satellite Innovation Program that Pete's mentioned in the introduction, of which I'm sort of part of. These are all companies that have developed particular solutions in space data applications. And, you know, in amongst themselves, they probably employ, you know, several hundred, no, not probably, they do employ several hundred people and turn over several million, actually several tens of millions of pounds of turnover in pursuit of, you know, how can we use new data streams, things that are actually being made available through the launch of big publicly funded satellites that are now freely available. Here in particular is the European Union's Copernicus program, which has launched the past decade and has changed the game in terms of data quality that is in the public domain. And so they use the data that's in public domain, they do some clever processing, and they produce an application. And this is the important thing, and we'll talk about this in a second. But, you know, that processing, you know, just because you have access to raw satellite data, that isn't information. There's a big difference between actual information. and these companies basically sit in that middle between data and information, and they process the data, and they come up with these data solutions, these platforms that help people do various things. So what kind of data comes down from space, right? There's, this is all in Arthur C. Clarke's papers from the 1940s. This is nothing, none of this is new. There's, generally speaking, three things you can do with what we call space assets, satellites out there in space. You can beam down a timed signal, something like GPS. We are now getting at the point at which these won't necessarily be just time signals, but they'll be also potentially quantum keys or bit keys or all sorts of things like that. But effectively, it's just to basically a repeated transmission of a very accurate time signal, which is how GPS is made of. All the hard work is done by your phone. The satellites are basically just sending out one simple signal. Communications, so that is slightly more complicated. Rather than the satellite doing the signal on its own, with a clock that's actually present on the spacecraft itself, communications or telecommunications is effectively a two-way game. So you need to send the information up to space, and then the satellite would then transmit that information to either a different part in the world, which is the way two-way satellite telecommunications work, or indeed in terms of satellite broadcasting, i.e. what used to be the Sky TV. These days, the TV often comes through the cable, though I suppose in many parts in the highlands, you're still very much reliant on satellite TV. In some places, well, also satellite internet, for instance. But in any case, so this is then signal sent up and then transmitted to a wider area, a broadcast to a wider area. And we have, and this is, to be fair, this is the largest bit of the space where space industry has been making money traditionally. There's a couple of very famous companies, particularly SES, which is a company based in Luxembourg. That's one of the largest global providers of satellite broadcasting services, and they're really the largest really space company that isn't in public ownership. Because a lot of, mentioned Lockheed Martin, Airbus, etc. These are effectively governmental contractors. They're not really proper corporations. They're not really proper private companies. They really very much make work for the government, and then they do some other little things on the side. But SES, for instance, it's a proper commercial company. And then finally, you have this latter, slightly elusive thing, which is we refer to as Earth observation or remote sensing. And this is effectively taking images of the Earth, taking images of the Earth using different kind of sensors. So it's not just the visible actual optical images. It is spectral images, so effectively just taking in the light and splitting that up and analyzing the light curve profiles of various, whatever you're looking down on Earth, as well as, in particular, very useful synthetic aperture radar. So these are radar images, so pulsating radar, and then looking for those reflections and see, in fact, in some really powerful, some very powerful satellites, they can do ground penetrating radar. So you don't actually just see the reflection of what's on the ground, and in shallow waters, you actually can even see, some centimeters, or even in some cases, up to a meter underground. So lots of exciting, tech. There's also some other slightly more obscure things like magnetometers and things like that. I'm going to skip those because they're not really commercially viable, and B, they're not really used that much, and they're not worked on that much in Scotland. But we can talk about those as well later if you like. But in general, these are the three streams of data in space: GPS, telecommunications, and Earth observation. So what does that actually mean for, what do we do with that, right? We've now at the point of raw data. Why is that interesting and useful? And why am I so excited about it? Why is there a Scottish space industry that's centered on these space data companies? So I'm sure you've all seen an image like this on your telly, for just following the news, and somebody talks about the weather. And this is a very extraordinary, and definitely not an ordinary image of the weather, because you can see the whole of the Great Britain, not the whole of the UK, but the whole of Great Britain at least, is pretty much free of cloud cover. Doesn't happen very often. But this image effectively is what the olden satellites, right, the ones launched in the 60s, 70s, well, primarily 70s and 80s really. We're taking, and it's basically just a low resolution, very low resolution. You can't really see the details of anything really here. Image of the Earth's surface, and you can just about infer some geological features like mountains and valleys and things like that. You can, of course, look for things like weather systems, etc., which is partially what they were looking for. But of course, the real crux of it comes when you actually can both improve on this image as well as process it, right? So take this sort of image into a processor, which looks for the small differences in the light reflected off the surface of the Earth that can demonstrate a presence of a particular feature. So I'll give you a little example. You take satellite data of a particular country or particular part of the country in Africa. This is in Senegal. And you have the satellite raw data. You see, okay, there's a particular part of the country that we've got mapped there. But then you run this through an algorithm which produces an analytical map, right? So it stops from being, okay, this is a map of a river that's been flooding or not, and we can kind of figure that out. And you move that into an averaged index. You either look for a time series of data, so you compile lots of images at different times and you compare the different images between them, or you use some computational tools to highlight what you believe are particular signals in that image. And from there on, you can prepare mitigation strategies to do with the phenomenon that you've been tracking. In this case, they're looking for floods. They've basically done the analysis to map out what are the likelihood of floods, of flood risk. What's the risk of flooding in different parts in Senegal, and then they've prepared a political strategy for the government of Senegal to actually act on that and trying to help sort of alleviate that risk or trying to sort of mitigate that risk for the population of Senegal. So this is where it really becomes interesting, right? So we're not talking just about data, we're talking about analyzing data, and the transition between one and the other is done through geoscience, and that's not, and also advanced informatics. So you need the computational power to be able to compute the time series, or indeed the sort of noise from signal ratio of teeny tiny features in your image, as well as the insight as to what does that small difference in optical light profile tell you about the natural world. So you need somebody who studies the natural world and is able to match that to the remote sensing data. And this is really where a lot of the work in Edinburgh is coming to, and I'll talk about that later. Why is this so important right now? Well, one of the so important right now because we are facing a global challenge, or rather, we're facing multitude of global challenges. A lot of them, however, are connected to one common denominator, which is the climate emergency. But in general, the response to the current societal challenge of climate change, the United Nations and various sort of meetings, including, of course, we very much are looking forward to a global climate conference this autumn, possibly in Scotland. Now they're talking about, again, changing locations or whatever, but COP26, I'm sure you heard about COP26 on the news, global climate conference hosted in Scotland. But in any case, that is part of this framework of sustainable development goals. So the idea is that there is, the challenges, we need to tackle all of the challenges at once. We can't just focus on small bits of climate change. We're going to solve that, and then we're going to move to everything else. This is a systemic problem. We cannot tackle issues of, resource, taking out, burning too much fossil fuels in resource poor countries unless we tackle the economic challenges that those countries are experiencing, hunger and poverty and everything else. So the approach to tackling the current climate and environmental crisis is to kind of look at it from a sustainable development point of view. And here, again, satellite data can help because it can look for both the local as well as global perspectives from afar, right? So if it is, vast majority of the countries in transition or developing countries have an issue that, they don't necessarily have the resources to be actually adequately monitoring what's going on in the environment, etc. And so the ability to actually do that remotely from using satellite data is super powerful, so that we can actually understand both what's actual situation on the ground, as well as help develop adequate and effective solutions. That doesn't mean that that there shouldn't be engagement with local people. That's absolutely not the case. But in order to even understand the scale of the problem, the UN have frame this idea of sustainable development goal indicators. And if you read to the indicators, there's loads of them. There's, I think, 250 indicators, I think, and there's 170 something sort of subheadings, and then there's, of course, the 17 goals. So a lot of indicators. But if you look at some of them, I mean, some of them are really specifically things you can measure with satellite data, and others are what we call composite indicators, where actually satellite data can help understand a bit of it. So here I've sort of put side to side, there's, ratio of land consumption rate to population growth. And here we have an example of how you can actually image rooftops and cars, and you can track poverty and you can track population density based on those features. Remotely, from an office in Edinburgh, somebody can process data that's sort of scanned, a neighborhood in Delhi, and can give us an idea as to what's going on there, even though this person's never been to Delhi. And again, it's important then you also need to have somebody true. This is something we call the grand truth. But on the other hand, the idea is that actually we could all together develop a different kind of relationship to our planet through sort of a stewardship of our planet, because we can have access to this fascinating and globally scaled data sets, and importantly information, right? So it's not just in the image, it's in those green dots and those blue blobs that it can actually then map out and specifically highlight what is where and what isn't where. And I say there's plenty others, and this is all going in the direction of something that I've been sort of peripherally involved with. So there's something called Frontier Development Lab, which is a NASA-funded project in the US. And now we have a Frontier Development Lab Europe branch, which is sponsored by a European Space Agency, ESA. And our core challenge there is effectively the idea of something called Mission Control Earth. So can we develop new data streams using, because there's also the volume of the data. It's not just somebody sitting in Edinburgh that can look at the whole of the world. We will probably need help from machine learning algorithms and artificial intelligence to do the first swipe through things, highlight particular area of concern, and then use humans and human intelligence a little bit more targeted way to look only at things that have been flagged out, rather than trying to scan the whole of the world, because that just would never work. But in any case, so we're, the idea to automate data fusion and change detection, and then allow a strategic overview and coordinated responses on a global level, because that's the whole point, right? Sustainable development, one of the issues is you've got 17 challenges, and they're huge challenges, poverty, hunger, poor health outcomes, environmental deterioration on land, in water. I mean, you have, there's 17 really complex things, and quite, it's difficult to actually figure out how to tackle all of these things at once. And from that perspective, space can actually help, because it can allow for a really kind of broad view of the planet. I mean, of course, the blue marble was such an iconic picture, not only because it's pretty, but also because it gives that idea that, you can think about the Earth as a whole, a perspective we cannot really see when we walk down and around in our everyday life, but it is possible. And the more we can use that data and analyze that data to develop this global perspective, the easier it is to find global solutions to these problems we are facing. Cool. So who's going to do all this stuff? Here I'll mention the thing that, poor Pete had a lot of mouthfuls to go through in that introduction. The Space and Satellite Innovation Program, which is part of a data-driven innovation program. So Space and Satellite is just a part of this big investment in Edinburgh. It's not just the data-driven innovation, it's part of what we call the City Region deal. So there's a huge amount of money, $1.5 billion or something like that, that's been given to Edinburgh City Region, much like there's also a Glasgow Region Metropolitan Area deal, I think, and there's a Tayside and Perthshire City Region deal or something like that, T-Valley. There is the Borderlands deal, Regional Inclusive Growth deal, and there's similar ones. I'm sure there's one near you in Moray and Aberdeenshire, or Moray and Highlands. I don't actually know that from the top of my head, but as part of our city region deal, a lot of funding has been actually put towards developing data solutions, because this is something that Edinburgh is really good at, and Edinburgh as a city has a lot of infrastructure that can be meaningfully deployed to look for what a smart city looks like, as well as how can you use a place like Scotland to model out these global trends and then go and actually try and really do some really big sort of public good service, not just to ourselves, but to the whole of Europe and the whole of world. A couple of things that just to highlight, there's different places in Edinburgh where this is happening, but the whole interesting part behind the data-driven innovation program is that whilst it is led from Edinburgh and we're trying to do a lot of work that is about sort of getting the expertise out, I've been working very closely with Fife and Scottish Borders. We've recently done some reports as to how we can actually extend the work that the data-driven innovation program is doing in those areas, and we're also working with partners beyond. So it's not just an Edinburgh place, even though all the shiny buildings are of course in Edinburgh. This is something I call the HAL 9000 of data-driven innovation. Is this kind of big evil eye that explains the whole program in one particular image. And you can see there at the bottom something that Pete has mentioned, that Edinburgh wants to become the data capital of Europe. This includes space and satellite. Space and satellite is one of 10 anchor sectors. In fact, is one of the 3 largest anchor sectors where we hope that data-driven innovation is really going to make a big difference. So by corollary, we want to make Edinburgh also the space data capital of Europe. There's particular ways in which we want to do that by upskilling lots of people in training our students, as well as CPD, so continual professional development. This is just for space and satellite, by the way. This is like we want to train 1,000. We want to have 1,000 outreach engagements per year. So I'll count all of your heads and add the tally to our number. And we want to train somewhere around 1,000 students. There's research outcomes that we have that we would like to have a particular sort of level of research activity measured in income, because that's how university as well has to live off something, so they measure it in money. But that's just one aspect of it. The critical point is that a massive upscale, tenfold upscale of research activity, 500 new industrial projects, 180 new data sets, 80 or 100 new companies, big ambitions, because as I say, we do feel ourselves that we can be the catalysts for this space data and space information sort of revolution, because on one hand, as I've shown you earlier, Edinburgh already is home to quite a significant number of space companies, and where there's the critical mass, more will be attracted to it. Secondly, we have a world-leading informatics school. In fact, it's one of the few places, one of the first place in Europe where artificial intelligence was explored back in the 1950s. And then we also have a world-leading school of geoscience, which is covering wide area of research, both in terms of sort of population, infrastructure, all the sort of human geography, as well as sort of environmental monitoring, particularly to do with forestry and land mass and land use. So a lot of interesting sort of expertise. So pull it all together, we've had this sort of before some of these companies, and this is kind of again the same representation in a sense that I showed earlier with Agile Space is just basically in reverse, and a slightly different slide that actually wasn't made by me, but a very good colleague of mine, who is Callum Norrie, who is a space network integrator for Scotland. So he's a very nice man. And if you look on there at the top, there's a bit that says data refinery, which has only our University of Edinburgh logo. So there is actually a unique place where this data-driven innovation, all the stuff that I've been talking about, we can do a specific thing, which is, as I say, bringing together 2 sides of the equation, the informatics and geoscience expertise, and enable the next phase, which is data analysis. So again, we have to play a role in data analysis, but as I mentioned, there are already companies doing bits of it, and there'll be more companies emerging there. But actually that initial crossover of the expertise is something that the data-driven innovation has been sort of built around for space and satellite. And so we're really hoping that we can push that in a big way. And so this is the strategy bit. This is the bit that we've actually developed a way to actually map out where the industry is going and how we can help develop it. And the reason why that's super important is because that big picture view that I've just talked about in terms of, can we measure, can we really tackle the sustainable development on such a scale? Without that critical piece, their data refinery, the whole thing can collapse. And right now that expertise is firmly held just in one place in Scotland, and we want to spread that more widely. One The thing is developing a smart plant resilience for development, SPRD program. This is something that's kind of in various, it's been proposed, then it disappeared, then it came back again, etc. But just to give you a bit of a flavor as to how these different kinds of expertise come together, there's on one hand, you have sensor data, you have the data, then you have the AI-powered processing analytics, and then you have the third bit, which is the bit that I'm going to be talking in the latter part of the talk, which is effectively the social science. And this is really somewhere where I come in. Though I'm a physicist by training, I specialize in astronomy and astronomical instrumentation. These days, what I really look at is sort of how do we bring social science in? How do we bring people perspective in? How do we make things more real on the ground? Whereas we are talking about all of these sort of machine learning algorithms and, all sorts of sort of acronyms and words that don't really mean much. How do we create a space where you can actually do advanced socio-economical and socio-ecological modeling so that we can actually basically tell and predict to a degree what human behavior, human responses will be, but on the other hand, also invite humans in and let them both scrutinize the work of these autonomous systems, as well as have a meaningful role and meaningful impact in deciding what their priorities and objectives should actually be. Cool. So why Scotland? So what makes the difference? Why is this happening right now? Why is this happening in Scotland? A couple of quick points. First of all, Scotland is something that we regard as sort of a living laboratory. So in order to do innovation these days, you need to have a certain vision. And particularly, if you want to do sort of space satellite data innovation, what you really need is, first of all, the environment you're going to scan. Then you need a physical and digital infrastructure with which you'll both capture what is happening in the environment, as well as compare that to the ground truth. You need the research capability, somebody who's actually going to do that. You also need those people that we want to bring in. So you need the workforce and community that's actually educated to the standard that you can actually engage in deep discussions around what actually it all means. It's helpfully if it's got a kind of a relatively distinct boundary politically, economically, geographically. So you define a space and you say, well, this is what I'm looking at. It's not like the whole of the US. It's Scotland. It's smaller. It has a certain degree of homogeneity. There's of course varying differences, north, south, slightly less east, west, but north, south in particular. But it is one unit. And it's good that it's the size it is, because if it was much bigger, it would be much more difficult to argue for development of a dispersed data pilots and all the various projects that we're working on. So it actually ticks all the boxes. Here's Scotland in comparison to this, ideal living laboratory for space and satellite, and it ticks all the boxes. So great place to be. Which brings me to Steve. So Steve is a good friend. He runs a company called Astrosat, which is one of the largest space data companies in Scotland. And Steve's motto is that every problem has a space solution. So effectively, whatever your issue is, if you ask Steve, he can provide you with something. We can provide you with a solution that's going to help you solve it. And he's been doing it. He's been doing it for a very long time. I'll give you one example of the work that his team at Astrosat are getting involved with, and that is monitoring coastal erosion. Now, I don't know how much you know about coastal erosion, but basically, the beach is being eaten by the sea all the time, right? Because of the tides and because of the wave activity. If in many places, sand or rock or pebbles or whatever it is slowly being sort of drifted away and eaten away. But by law, councils are actually required, and councils in England have, I think the framework is slightly stricter here. They share that responsibility with Scottish Environmental Protection Agency, so SEPA. But in England, it's a council responsibility to know what's happening to their coastline, to monitor what's happening to their coastline, and to propose appropriate mitigation measures, which basically means people going in, rangers being dispatched to sort of drive along the beach, measure where the sea is, measure how much sand there is, and then keep on repeating that year after year, which is super costly and extremely inefficient use of the limited resources that they have. I mean, the rangers could be doing much more useful things if they haven't had to just go and literally look for where sand is, which is from a conservation point of view, that initial assessment is actually relatively trivial. So Steve has been working with something called, as a place called New Forest District Council in particular, where they've done the pilot, but they're also part of a kind of a committee or a conference. They call themselves Standing Conference of Problems Associated with the Coastline, which is an association of local authority areas in England who have exposed coastline and have to deal with all these issues, legislative issues, etc. And they were also funded by something called Space for Smarter Government program, which is the UK Space Agency funded program that enables this sort of collaborative projects where, you know, Steve didn't quite know whether this will work or not. The council didn't quite know exactly what they're looking for. So the Space for Smarter Government basically gave a little bit of money to allow them to explore this opportunity. And then once it was defined, sort of, you know, they can go on and just develop whatever they want themselves. And one of the reasons why I'm highlighting this particular project this year is because we are, of course, in the year of the coastal areas or something like that. I always forget exactly what it is. So the Scottish government, you know, announces every year that there's a particular focus for sort of various kinds of activities in outreach, public engagement, you know, community development, all sorts of things like that. And this year, I think it's coastal waters or something like that. My brain had frozen for a second, but and so, you know, topics like these are particularly specifically acute and being discussed this year. So this is the solution, by the way, right? I've not just forgotten about, you know, we need the solution. So they've developed a tool, an analytical tool called Coastal Sentry, which is using synthetic aperture radar. You can see there a bit of the coast, both in what it looks like from a photo that a ranger took, as well as a little bit of coast. And you can't see that very well, but there's a plume that sort of goes off the top corner there of that peninsula. That is actually sand being pulled away into the water, and that is being monitored, and you can kind of quantify from space just how much sand is being pulled into the water on daily basis. So you can actually, well, not quite daily basis because the revisit rate. So every time you get a photo, you can measure it. And it's not always it's going to be the next day. Sometimes it's a couple of days in between. Sometimes clouds come up, although they use synthetic aperture radar, which actually can see through clouds. So that's not so much of a problem. But it can monitor on weekly, monthly basis, you know, probably more accurate than they need to, because they need to report only on yearly basis. But it actually enables a much more real-time capability in looking into these things. And this is, as I said, this is just an example that's perhaps particularly relevant this year, but one of many tools that have been developed using this Earth observation data to process images and come up with useful information for local authorities, communities, etc. So finally, right, I mean, I've shown you some satellite photos. I've shown you some reasons why they're useful from sort of sustainable development global point of view. I've also shown you some, you know, more specific, slightly more direct example here with the Coastal Sentry. But what does it actually mean for you? You know, neither of you personally are the whole of the local authority. Neither of you are legally obliged to keep an eye on your coast. And whilst I'm sure you're all very much aware of the climate emergency and the complexities of the challenges that we're facing across the world, you know, it's absolutely the case that it's none of our personal responsibility to save the problem that the UN has been trying to tackle for the past 30 years. So how do we actually connect to these global pictures, which somehow seem so remote? You know, you see these satellite images, and on one hand they're beautiful and they create a different perspective, a different connection with our planet. But on the other hand, the scale is just not human scale. You're not walking along those images because, you know, we talk about, you know, hundreds of kilometers wide. You know, the resolution is not a human. It's a much bigger thing. And here comes the thing that is absolutely brand new, straight off the press, launched yesterday. So one of the things that we're also doing in Edinburgh is not just to say, well, we're going to develop and support the industry and our researchers to come up with new solutions to look at space and Earth observation data, and come up with sort of information that's useful for councils, etc. But we're also going to work on trying to make sure that people understand what's going on, what's at stake, to open up perhaps some debate and discussion around what these global perspectives are doing, and how are we all part of the same picture. And here we worked, and this is a project we've been working on for the past 8 years. And as I say, it launched yesterday, hooray, 3rd of June. If you go to the website awen.earth, you should be able to find a link straight into launching the experience. It's a mobile or tablet experience, so you have to use a mobile device to do it, and it has to be a device that has internet outside. I know this is difficult in certain places, but you'll have to kind of find a solution for that, I'm afraid. And it's basically bringing together both the environmental science as well as a more kind of reflective approach to engaging with your surroundings. So we were working with renowned artists and interaction designers. So the artist is actually something called Ines Camera Leret, who is based in Paris and London, Madrid and London. She's absolutely amazing, and she developed this really poetic language and expression in this experience, and she also narrates the experience. And we worked with Ray Interactive, which is a design studio from Dundee, who've designed the sort of the application and the interactivity and the various buttons and all the things that they do. And we worked with Tom DeMaggio, who is a composer. He did work for National Theatre, etc., but he's also done work for us and in creating the soundtrack for the experience. And it's powered by Earth observation. So we are taking actually images, processing the images and serving them as part of the experience in different ways. Some of it is just about what kind of experience you see. Some of it is actually showing you some of the data and asking you questions about the data, or asking you to kind of reflect on what that data is or isn't telling you. And effectively, you can all take the walk, you can basically just load, open it on your, it's a browser-based application, so it's not like an app. You just load it on your phone in your browser. It best works on Chrome if you've got an Android phone, or Safari if you've got an Apple phone, an iPhone, and you'll see it's super self-explanatory. So you basically go on a walk with it, and you can go any direction you like, but there will be sort of prompts guiding you to engage with particular things in your surroundings as you go along. And because you can go in any direction you like, and you can of course change that at any point in time, you can actually take this experience as many times as you like. And every single time it will be slightly different, because you'll be engaging with slightly different things. By the way, I'll also say one important thing. It's a prototype experience. So we developed this with a partnership with Edinburgh Science Festival, which is launching on 26th of June. We did launch a little bit in advance because we want to have a slightly extended sort of prototyping period. So we basically want people to give us feedback. There'll be some questions at the end of the experience where you can actually leave some really meaningful feedback, and we invite you to do that and to go through and let us know how this all feels. But the whole bottom line is trying to again create a connection between this global science and global modeling and global data and global information and the things you see in your environment. And I think we hope that that's going to be quite powerful, and a collective call for action as well. All of us taking these walks to be perhaps more serious about our climate emergency, and maybe there's political things and social things and other things we can do further down the road. I mean, we are hoping to actually have this as part of COP26. So we'll see how it goes. Finally, just a couple of observations. There's just to mention a couple of cool, interesting little explorations. So one way to do it is to kind of go and do the experience. I work a lot with arts, trying to bridge the various questions that are being posed by looking at the data and the space science and the information that is providing us. So we've recently published a book called Scotland in Space, which is a collection of short stories, commissioned short stories, with some social science and natural science narratives that are kind of exploring some of the backgrounds to the various stories. And the question really is, how are we changing our thinking? Here, this is a very grand word. It's because I nicked this slide from a presentation I gave to a symposium about data ethics and artificial intelligence. But how are we thinking differently? How are we having a different connection with the world because of the scientific opportunities that new technologies, including space technologies, are bringing to us? Is a really pertinent question, and this book, amongst many others, is exploring that. If anybody is super keen, let me know. Actually, there's an interesting conference happening in Edinburgh next week that you can join online. It's still free. It's Eventbrite. It's still super free. There's talks every day, lots of very different kinds of expertise. It's called the Institutions of Extraterrestrial Liberty. It's a little bit more outer space oriented than is this space oriented, but we're exploring exactly these sort of topics as to how are these new technologies and new perspectives of life in universe and life on Earth changing the way we think about each other, and the way we maybe change the way our institutions work, or critique our institutions and politics and other things. So just to wrap up, this is all coming to the point that actually we are starting to talk about something we call transplanetary ecology. Now that means everything and nothing. But effectively, we mustn't forget that those satellites we launched out there in space are very much part of our earthly ecology in a sense. We think about them out of sight, out of mind, but that's problematic. Problematic for various reasons. I talked about one reason the last time I visited with you, which is, of course, the space debris, and just the fact that they are both obscuring the night skies at times, particularly if you're launching mega constellations of thousands and thousands of small satellites with relatively high albedo reflectivity. Then that's a problem. And our good friend and colleague here in Edinburgh, Professor Andy Lawrence, has written a book about it. So if anybody's interested, please make sure that you look into basically just Google Andy Lawrence constellations or Andy Lawrence. I'll try and remember, but before the end of wrapping up this talk, as to what his book title actually is. My brain just froze again. But there's that aspect. We mustn't forget that everything we launch out there is very much part of what we're going to see from the Earth, as well as that by sending more stuff out there, we are expanding our own perspective on our own planet and also where we are in the universe. For as long as we were just on Earth, we were a single planetary species. This is something that Elon Musk, as much as I don't necessarily like him or like his ideas, is talking about all the time. So the further away you go into space, the more you as a species basically become different, and our ecology is now being extended to other places like the moon, like Mars, other planets, all of this stuff we have flying around the Earth, all of these satellites. And we need to be just a little bit more careful as to what we're sending out there and think very carefully about how is that changing our perspective back down here on Earth. And that's enough because it's already 5 minutes past 9. So the last point was really mainly for further discussion.
Hey, thanks, Matjaz. That was a great talk, and we've got a few questions here. One from Bill, which he sort of says, thanks very much for a very interesting talk and with lots of information. I agree with that. It was a pretty, not dense, but a great talk with plenty of information there.
It was a bit dense. It was a bit dense. It's true. The problem we are having is that there's so many developments. I mean, one of the reasons why Pete was struggling with all my titles is because there's just so much stuff going on. It's not that I'm selfish and I want to be the one who does everything. Far from it. We are super stretched. We need more people to get involved in this area because it's growing so super fast that if I was to leave out, I mean, I've left out a lot. But if I was to leave out any more, next time I come and talk to you, you'll be like, which planet is this guy from? Because there's a bit of the story missing because there's just so much stuff that we're developing.
It's the inevitable, problem with having a lot of information to choose from, though, isn't it? It's anyway. We've got a great question here from Bill Graham, who says, "How will Scotland incentive compete with the assets of, say, the EU, and how will it differentiate itself from its bigger competitors?" A sort of, what's its unique selling point, I guess, is the question, isn't it?
Yeah, absolutely. So Scotland's unique selling point so far was that it's a one-stop shop for small space systems. It's not quite true because the rockets still haven't been flying from Scotland yet, but that should probably happen some point soon. And then we really are relatively unique that in one relatively small geographical area, you have the whole of space industry in small. And you can, if you need a satellite built, you can go to Glasgow, you pop over to Dundee to get your data downlink, you go over to Edinburgh, get the analysis done. Your rocket's been launched from, Sutherland or perhaps, Western Isles or maybe Shetland. So from that point of view, I think it's a really, really interesting proposition. In terms of competing with the other people in the EU, well, of course, there's lots of competition everywhere. There's no such ecosystem per se because there's always the people in some of the Nordic countries are developing space launch capabilities, but they don't have as much of the space satellite manufacturing or data analytics assets. There's places further down south, particularly south of France, where they have this is the biggest nexus for satellite manufacturing in Europe. But nonetheless, first of all, they're still focused on slightly bigger satellites, as well as not having neither the launch facilities nor the data analytics. There's big data analytics centers in Germany, but they don't have the other two. So in interesting ways, Scotland is quite unique that it has little bits of everything, but all the bits of everything need to evolve together in order to remain globally competitive. I think the point with the EU is that, the hope is that we're not going to compete, but that we're going to collaborate and cooperate. Whether this is possible and how is this possible under the current political climate is a different question. But the general, on one hand, European Space Agency is beyond the EU. The EU actually tried to be a more central place, a more central role, and does actually fund a very big chunk of European Space Agency. But European Space Agency has members. Well, UK is a member, but not only is the UK the member, but there's also has some members or kind of observer members that are not even anywhere near Europe, like Canada, and so they've got a much more open door policy than perhaps you might think. And from that point of view, I think there's a lot of cooperation that will be going on further into the future. I think the question is really not EU, but particular countries. And there we are seeing that some countries are tending towards being more competitive, and some of them are tending to be more collaborative. And that's unfortunately the reflection of their current political persuasion or the majority opinion. And from that point of view, I think we might be just a little bit of the problem ourselves, because we are kind of competitive. We do set our stall to say we are the best, and that's not always ideal scenario when you want to negotiate and bring more people around the table. But there are really promising things happening right now. There's a pan-European initiative of cluster integration. And in fact, I was involved recently in discussions of how to bring a Moray-based space industry around Orbex and affiliated companies and developments, and a bit of spaceport in closer cooperation with a cluster in France. So actually these initiatives are happening, and the hope is that they'll continue to happen. And with the recent announcement that, at least on the research side of things, the UK is continuing as part of the European Research Council and is going to be part of what we call Horizon Europe, which is the next huge sort of funding package for academic research in new technology, new science, all sorts of things. That is a super positive announcement. That basically means that we very much remain part of our European family, EU in or out notwithstanding.
Yeah, well, that's good. That's good. It's some, we've got to work together, though, haven't we?
Absolutely, absolutely. Because the big competitor, of course, isn't Europe; it's the US, right? If Glasgow likes to say that they are the city that's made more satellites than any other place outside the US. So there needs to be that qualifier. US is still a titan of space industry and space exploration. And for a lot of people, it's still the place to be. So the question is, how do we attract some of that talent here? And actually, Scotland has been quite successful. There's a company called Spire, not in space data, actually in hardware, in making small satellites. They do the whole hog. They make satellites. Someone else launches the satellites. They actually manage their own downlink stations, and they do the data analysis, and they sell the data to insurance companies and other markets that they work with. But the interesting thing about them is that they're a US company that was attracted to Scotland by a combination of initiatives and the right kind of technological expertise and the right kind of physical technology they can get their hands on. And so they relocated to Glasgow from Silicon Valley. So big success story there for Scotland. So I think the question is, how do we make sure that that center of gravity, collectively, the whole of Europe and probably also looking a little bit closer cooperation perhaps with Russia, how do we collectively move that center of gravity a little bit out of the US? Because so far it's really been very US centric, and with people like Elon Musk, it will very likely continue to be so unless we all work together.
Well, I guess we just put the money into it, don't we?
Well, yeah,
that's what America's done, and it's put the money in very effectively.
Absolutely, put the money in it, and as well as there's not just money. There's other kinds of capital as well: political capital, social capital. There's will. Where there's will, there's a way, and where there's will, you'll find the money. But there has been a lot of sort of more narrow-minded sort of nationalist views of space development. Space is seen as a critical infrastructure. Space is seen as something that's closely linked to defense and national security. But actually, it needn't be just so. And in fact, there's a lot of international agreements that UK and other countries have subscribed to, which explicitly forbids the use of space for military purposes. And so far there has never been a war in space, but it's come close to kind of doing sort of hostile action in space. And if we perhaps were to take a step back and think about this differently, I think there might also be ways to politically come closer together. And then once that happens, the money is always found, as we've seen with recent pandemic. If something is, if we recognize, let's say, climate emergency as a threat that it is, and say, well, actually, space is an important part of the solution to that. As soon as we take that seriously, the money can be found.
Yeah, I guess the money can always be found if it's, you mentioned earlier on that the space industry was quite spread across Scotland. Do you think that confers any particular advantage? Is it good to have it concentrated or good to have it spread? Because I know Formula One's, you can see about 2/3 of the Formula One industry from a hill in Oxfordshire,
Yes.
It's but that's reckoned to have a real advantage, because if you need a top class exhaust and a coating for it, somewhere within 20 or 30 miles there's a company that can do it. It's
yes. So we argue, so I've got a bit of research out that actually we argue that is an advantage, and that because the advantage is that space industry, because it's dispersed, it mingles more with other industries and it stays more relevant for people who actually, who are the users of the technology, rather than talking just to itself and forgetting about what the real world is doing. I mean, Formula One can afford to talk to itself because its vast majority of revenues is from advertising, right? So they don't necessarily have to produce anything that's really useful to anyone, as long as they put on a good show. So concentrating something that is effectively in its own bubble is less of a problem. What we've seen both in different kind of industries. I think that the thing with space industry is that it's got a very long value chain, right? You need the hardware, you need really advanced manufacturing and engineering. You need, data and electronics specialists. You need, processing analytics. You need the geoscientists, the social scientists to actually interpret the data. It is a critical infrastructure, so it has a lot of sort of other implications as well. And of course, it also has all sorts of kind of political, so that it needs a lot of expertise. And because of that, it's not like IT. IT, you can start up an IT company in a garage. You need to have a laptop and some coding skills, and you can draft together an app. You don't necessarily require the level of expertise that a lot of the companies in the space industry require. So from that point of view, it's actually not, the Silicon Valley model, doesn't work either. So actually Scotland is doing quite well because the dispersion means that people talk to other bits of expertise, and they can draw upon their local heritage in terms of knowledge and experience. So it's no coincidence that a lot of the manufacturing is based on the Clyde, in Glasgow, but effectively drawing on the engineering tradition on the Clyde, and advanced engineering that's still present in nuclear and Trident and all those sort of things, BAE systems there. And similarly, it's no coincidence that Dundee has a huge electronics and data analytics center, and now game industry and all that sort of stuff. That's why a lot of the hardware electronics is actually built in Dundee. Edinburgh, as I said, traditionally in AI. So, the geosciences are being plugged in straight into the sort of an AI nexus. So from that point of view, actually, that has helped each part of the value chain grow much faster and much further than they would if they only just talk to each other and just try to match each other's requirements. Because, they were challenged by and were able to absorb expertise from outside the industry, which enabled them to be, more interesting, more competitive, make better stuff.
I was going to say, Matt, you said you're spread very thinly, aren't you, over all the different things you do. I'm guessing these are paid positions, are they? Is there jobs, or is there jobs involved in this that could, people could actually get into?
Absolutely.
Yeah.
There is a European Space Agency has a lovely chart that says, like, we need everybody. And there's another leaflet that I think I brought some of them with me last time I was up there. That the Space Careers has made, which basically says, well, we need lawyers, we need doctors, we need everybody. Space is open to everyone, and yes, there's absolutely loads of jobs. There's specific, so manufacturing jobs will be concentrated near manufacturing centers, but a lot of the data analytics jobs are actually spread quite widely across the place, because whilst the company might be based in Edinburgh and in the pre-corona times, the benefit of having an office in Edinburgh is vast, because you can walk down the road and speak to a world-leading AI specialist. Today we're also used to Zoom, etc. But I think we will also see a further spreading out of the industry, because of the fact that people are able to work from their homes. And in Scotland, there's many lovely places where you can
contact people easier.
Yeah. So absolutely, loads of jobs. I mean, the growth in jobs over the past 20 years or so has been, I think, something like 12 to 15% on annual basis. It's huge.
Amazing.
I mean, when the first space industry event I've been to in, I think, 2013 in Scotland, there was probably 35 people there, and they represented pretty much all the companies in Scotland were there. There might have been twice or three times as many employees around, but that was about it. That's up from maybe about 5 that you'd find in 2003. 2021, there's no way to fill a room, even if we could meet in person. We need a big conference center, perhaps. Hundreds and hundreds of people, hundreds of companies, each of them with tens of people. So in the whole of the industry, several thousand people. Absolutely massive growth. So
it's good.
Lots of jobs.
As a positive, that's for sure.
Yes, and some of them around the corner, right? I mean, Orbex
yes,
is a little bit of a slightly secretive company. We don't necessarily know exactly what happens behind their fence, but
no, we tried contacting them, and it's like nothing comes back. So
yeah, I tried to contact them for research. Not much came back either.
I tried to contact them to do an article for the Knock News, and I just didn't hear anything.
No, I think you said very secretive. So it's not us then. It's them.
Well, it is them. But they have promised, as part of the funding package they received, I think they promised 120 new jobs in Moray. So
yeah,
I hope you get that. But either way, spaceports are coming. There's a lovely company that is developed there at 4S, which is called wireless something. Completely gone from my head. It's effectively developing a distributed Wi-Fi system that kind of downlinks satellite data. So you create a remote hotspot or remote Wi-Fi hotspot, which of course is super useful for the Highlands, but of course also for many places around the world. And they've been, absolutely fascinating work that they've done, 10 years ago. I don't actually know exactly what they do right now. I know they're spread in between different places. They've got bits in Scotland. They've also got bits in the south and in England. But yeah, so tactical wireless. There we go. Tactical wireless. I think it's called.
There we go. Yeah, so it's really, really interesting because you said that it's not one person's responsibility, this, but I think everybody does have a responsibility, don't they?
Yes.
And there was one thing that came up in our sort of committee when we were talking about the polystyrene cups we were using for the break time. We decided, and it was Don actually said it. Said we're, as astronomers, we're always looking up. Sometimes we need to start looking down again.
Yeah.
And in that meeting, we decided, right, we'll go to compostable ones. So it's a little thing we did, but hopefully it'll all help.
Well, Zoom committee meetings are saving a fair amount of petrol as well.
That as well, yeah, and that's something we are going to carry on doing.
Yeah.
So, in the committee especially. But, anyway, Matt, I thank you so very much for that. Really enjoyed it. I think
another thing you can do to get well.
Yeah, well, I go walking all the time, so I've already got the app downloaded, so I'll be good doing that probably tomorrow if I'm feeling okay.
Perfect. Well, yeah, you and me both. Fingers crossed.
Fingers crossed. As I say, we're going to just give you a little thank you, if I can get this to show. It's a crystal tumbler. I think you may have had one before, but
but they are beautiful.
Yes, so a matching pair is always better than just the one.
Absolutely. Well, you have to drink whiskey with friends. You can't do it on your you can do it on your own, I suppose, but just a bit sad. So yeah, absolutely. I'm delighted. Thank you so much for
no problem at all. So to say, if you haven't given Rich your address yet, please do so, and we'll get this off to you as soon as we possibly can. And thank you so very much. And we will be asking you back. There's no doubt about that. Okay.
You're more than welcome. And
we'll get you up.
Yes.
We will make sure that it's when you can come up, and we'll take you to Lake Murray for a meal and that beforehand, and get you.
As bad as that is for the environment, I'd love to see you all in person again, and hopefully we can time it so that perhaps it kind of coincides with maybe some more activity up in the area, so we can kind of do some
Yeah.
fuel efficiency if nothing else. But it'd be lovely to see you all. It's been a pleasure meeting you the first time round. Of course, it's been a pleasure meeting you all before at Orkney Science Festival, etc. And I'm really looking forward to seeing you all
No
again.
problem. Well, say if you want to hang around, and say we'll set the link up in a minute to the gathering. If you want to meet some of the other members, you're more than welcome to come along. But as for now, thank you very, very much. Okay. Well, I just finished off with a little bit of the club news. And say the BAA summer meeting, this might be one of the ones that you might want to come up for. As you know, the BAA planned to hold a summer meeting last year. Was that 2020 last year, wasn't it? I'm losing track myself. That was postponed to this year, but obviously that's now been postponed until 2022. But to make up for this year, they're putting on a couple of talks. That's on online talks, that is, on Saturday, 26th of June. 11 o'clock talk by Dr. Nicholas Peretto, and then we got Dr. Amy Bonser, get my teeth back in, at 2:30. As I say, links for that can be found. I think I'll put them in the newsletter. I will get them up on the website, but you just go to the BAE website and you can find them there anyway. And just carrying on for that, there is a date now set for 2022, which is going to be the summer meeting in Elgin, and that is on Friday the 7th and Saturday the 8th of September. So that's a date for your diary, and we'll start getting it organised with the BAA to get the people up here to do some wonderful talks for us. Physical meetings, let's say we are looking closely at how possible it is going to be to get back to physical meetings as soon as we can. But there's one thing that Rich brought up when I was speaking to him the other day. I'd say these little things, little chats we have, is that the one thing we don't want to do is to open up, going back to physical meetings when we can, then all of a sudden find we got to close down again, a little bit like people going to Portugal, you know. We really want, if we're going to open up, let's get it and make sure we're going to keep going all the time. But we will look at the situation closely and keep an eye on that. Observing sessions, though, could be another thing, because I say restrictions are being lessened just a little bit at the moment. So hopefully come the autumn time, we can meet up outside and do some observing again. That's what we're hoping. Don't forget the Sigma on YouTube channel. You can catch up with previous talks we've had. And this one will be open to members in a couple of days' time. I'll send the link out. You should want to have the link for that. If not, just do a search for it and it will pop up. The Sigma telescopes, when it starts getting dark again, would someone please have one of these telescopes? I need the space in my observatory, please. Someone just hire one. Okay. All the information about that is in the newsletter again. As I say, I think Rich has already put the link up in the chat, haven't you, Rich? For the Zoom gathering. You have? Yes, that's fine. So once I finish here, if you just click that, yeah. Once once I'm done here, if you just click that, it'll ask you if you want to leave this meeting and then go off to the next one. Don't forget, if you've got anything from me, let me know. Give me a call, give me an email. Just any ideas you might have, just send it to me, because I say this is your club, not my club, or the committee's club. It's your club. Well, it's our club, really. We're all in it together. Next meeting, as Donna said, it's Professor Ian Morrison from Jodrell Bank. Now, if you remember, I'm trying to think how many years back it was now. I think it's probably 2012. We had a joint meeting with Haz. This was Dr. Ian Morrison who came up, gave us a talk on our Friday night, and then we had a joint meeting in Nairn on the Saturday. He's a fantastic speaker, one definitely not to miss. So once again, put that date in your diary. But when I send the Zoom link, pop it into your Google Diary. That's the easiest way to get your links coming back out. And he will be going over wonders of the southern skies. So we'll be able to see some of those things that are always hidden away from us by our horizon. So with that, I want to thank Matt for his wonderful talk there, Rich for handling the Q&As, Nick and Rich there's been the Zoom backup co-host in case anything goes wrong, went wrong with me, and for your good selves for joining along, and we'll see you in a few minutes over in the gathering. So for me and everyone else, good night.